Good morning, everybody. This is Kashyap Saharana, your host for today's conference. I warmly welcome all of you to the second day of 4th International Conference on Life and Chemical Sciences, organized by IM Group of Researchers. Today, we go onward on a journey of collaboration and knowledge sharing, bringing together young and passionate researchers from around the globe. Our platform, after 1 year of dedication, has hosted 3 international conferences, 6 webinars. Now we are driving into book chapters and 19 review articles, with 98 authors reflecting our commitment to excellence. And we contributed to social causes like Flood Relief Fund and Palestine Relief Fund. I would like to express my gratitude to the remarkable individuals who have played pivotal roles in our success. Dr. Fahmida Javeen, the Executive Director of and Patron-in-Chief from Bahauddin Zakriya University, Multan, and Dr. Adnan, our Director from University of Swat, who have been actively involved. I extend my deepest appreciation to the Honorable Professor Dr. Memuna Ghafoor Shahid, who serves as patron and co-patron, as well as our esteemed team members Azazul Islam, Mushtaq Ahmad, Miss Faiza, Dr. Sadia Bano, Miss Aksa Iqbal, Safia Khan, Dr. Sara Junaid, Maham Iqbal, Miss Riaj Iqbal, Atir Naim, and myself as well. Together, we lead this dynamic organization with unwavering dedication. Currently, I am doing PhD in chemistry from East China University of Science and Technology, Shanghai. So, as a doctoral researcher myself, I'm excited to be a part of this vibrant conference. I'm very grateful to all of you for joining us today. We will be shortly starting our conference, so if anyone from your friends is missing, please inform them to join quickly as we are all set for the virtual stage for our dynamic and inspiring conference. So let's start with our session with a few verses of Holy Quran. So I would request Mr. Idris Ahmed to please join for the recitation.
I am audible, him?
Yes, you are audible.
Oh, okay. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. اقرأ باسم ربك الذي خلق. خلق الإنسان من علق. اقرأ وربك الأكرم الذي علم بالقلم. علم الإنسان ما لم يعلم. In the name of Allah, the most gracious, the most merciful. Read with the name of your Lord who created everything. He created man from a clot of blood. Read, and your Lord is the most gracious, who imparted knowledge by means of the pen. He taught man what he did not know. Sadaqallahul Azim.
Jazakallah Idris. Now we will play national anthem.
It is with great honor that we extend our warm welcome to esteemed Professor Dr. Mohan Verma, a distinguished physicist and material scientist renowned for his pioneering work in computational material modeling in India. Currently serving as a professor and head of the Department of Applied Physics at STCC, Professor Verma is not only a prolific researcher but also an active life member of prestigious professional bodies such as National Society of Solid-State Ionic and the Material Research Society of India. With a remarkable expertise showcased in 45 research papers published in national and international journals, Professor Verma has significantly contributed to the field. His leadership extends beyond academia, having organized several national conferences and international conferences. Moreover, his successful completion of research projects, including Siesta and Quantum Espresso, underscores his dedication to advancing knowledge. Professor Wormer's profound insights have not only enriched the academic landscape but also have delved into cutting-edge technology. His work on emerging technologies like polymeric electrolyte materials and the designs of electrodes in nanoribbons and nanobelts for various electrochemicals and optoelectronic devices demonstrates his commitment to pushing the boundaries of scientific innovation. Please join me in expressing our deep gratitude for Professor Dr. Mohanlal Verma's presence today. We eagerly anticipate the wealth of knowledge and expertise he will share with us during this conference. Now it's over to you, Dr. Mohanlal Verma.
Well, thank you, ma'am, for this introduction. And my screen is visible to everyone.
Yes, sir.
And it's
Yes, sir.
I can see it.
and my voice is clear.
Yes, sir, your voice is clear.
Okay, okay, okay. So first of all, thank you, the organizer, for inviting me to be part of this wonderful gathering, wonderful workshop. And the topic is that I will talk about this computer-based experiments on some polymeric materials. So first of all, I would like to thank my guide, Dr. Rakesh Chandra Agarwal, Professor Ravin Chandra, the mentor, and my friend Rodrigo from Brazil. And because of all these three, I am able to present such type of work in front of this good gathering. I'm also thankful to my research team. Actually, I just work on different interdisciplinary subjects, and my students are also from different domains, different subjects. So, and also working on mathematical modeling, experimental physics, as well as computational physics. So my students are of a different stream. So these are some students are experimental, some are mathematical students, and these are my DFT-based students. And 8 students have been awarded their PhD works, and 3 more are waiting for the award. And 3 new students joined me recently, and many more students are directly and indirectly connect with me to work in DFT. This is my institution, Sankaracharya Technical Campus, and this is situated at India, one beautiful state, Chhattisgarh, and my research lab, the computational as well as experimental research lab, and the very old picture of that 2013, where I have organized one international workshop, and this was the turning point of this research in material modeling. The computational tools I am using here in my lab, and I generally prefer to use that tools. These are free of cost, because I know that there are so many software-based research running in the field of material modeling, and most of them are commercially available tools, but I generally use all these tools which are free of cost. Now the outlines, since this my study which I am going to present here, it is related to density functional based theory. So just I will give a glimpse on this density functional theory, and I'm using Sista. This is a very wonderful tool. So I will also introduce this tool, that computer experiment through Sista. And since this is related to polymer, my topic is, so I will show some result which we have performed in my lab. Otherwise, you know that there are several types of polymers, that are dielectric based or insulating polymers, semiconducting polymers, ionic polymers. So I will just show some results related to the work we have performed in my lab computationally, not experimentally. The motto is, all research methods are complementary of each other. we cannot say that experimental research is good one, computational is not good, or mathematical modeling is so boring. No, no. Every part of every stream of research is very important. Otherwise, that result will be shown in this cartoon. In general, I generally give talk with starting with this cartoon. If we are not working together, then the result will be random. Now, what is this material modeling? Material modeling is actually the designing of material for different devices. And when we design this material by using computer, then that is known as the computational material. And this is the very wonderful method to which handles the materials under extreme conditions at high temperature, at high pressure, and those extreme conditions which cannot be attained by laboratory methods, we can use we can study those materials by computational methods. And one thing I would like to say here that mathematical modeling are that molecular modeling is not a computer game. Sometimes in earlier study earlier time, I generally heard from some experimentalists that this is just playing with atoms. This is animation time, but no, this is not true. And this material modeling is now a new frontier for the design and discovery and testing of new materials before device fabrication. And this has clear-cut objective to better understand and predict the properties and performance of novel and complex materials for devices. This focuses overall on understanding the interaction between atoms and a group of atoms. So that material modeling, this is atomic level, and when we just shift to DFT, then this is the time and length scale. We generally use this DFT based tool, which is in the level of quantum mechanical phenomena, means atomic subatomic level studies, and we use this equation, that Schrodinger equation. So that length scale is in nanometer and time scale in picosecond and nanosecond. Why DFT? This DFT is presently a very successful approach to compute the electronic structure of matter. So this is that electronic level studies of material. Its applicability ranges from atoms, molecules, solids, and one can go up to the nuclei in quantum and classical fluids. And its original formulation, it provides the ground state properties of the system. And here we give the emphasis on electron density, which plays the crucial role in this study. And now DFT is used in different field of chemistry, physics, and almost all branches of science. If anyone wants to deeper studies of DFT, then I would like to say, once you start from this original papers of DFT, some review articles and some good books, these are the list of some references. One should start from this. Now, since the DFT is electronic based study, so we should start from that electronic structure theory. We know that structure of atoms, that nucleus and electrons are moving around that, and also that Moseley's statement, where it was told that physical chemical properties are the periodic function of atomic numbers, and these atomic numbers are nothing but electrons. So in the DFT, if you want to study the DFT, we should know about the electronic structure, and I will not go to the details of that mathematical formulation, but I would like to say here that by using this electronic structure theory, we can have that transport properties, optical properties, magnetic, electronic, superconducting properties, electronic properties, and catalytic properties, so of the materials. Now we know about that Dudek models, Lorentz models. So that study started from the invention of electrons, and after that different models in the materials where electrons moves in the random manner, and there are so many some limitations, and to overcome limitations, a new theory or that statements come from different scientists. So we will start from this Dudek models and then shift to that Sommerfeld models, where and which is further modified up to this Bloch theorem for periodic structure, because initially that was related to simple materials, but in order to study the crystalline materials or the solid materials after Brag's discovery of X-ray diffraction and the structure of that material, and then the quantum mechanical phenomena, and that this statement given by blocks. So and that band structure, etc. So this is the development, successive development of that electronic theory to DFT. This is that band plot given by this on the basis of that block theorem, and basically we have to know about that many particle problems using that Schrodinger equation, and in the journal it is says that that Schrodinger equation is good for two particles analytically and a few particles numerically, but we have in very simple solid we have about 10 to the power 23 atoms. So these many body problems, and to solve this Schrodinger equation for many body, it is very difficult. So, and there are different types of interaction in electronic level. In particular group of solids, we have electrons, nuclei. So there will be the kinetic energy of electrons and nuclei, some repulsive force interaction between pairs of electrons and pairs of nuclei, in between electrons and nuclei, and these are that mathematical terms related to those. But I will not go to the details of this mathematical term, but here just I want to summarize the terms. This is just the conversion of that Schrodinger equation to quantum equation, where this wave function psi, which actually contains all the properties in it as a function of position and time, it's converted into charge density, and that the development is from starting from this Schrodinger equation to this Born up BO up approximation, where this mass of nucleus, it is much considered as much heavier than the mass of electrons, so it's taken as fixed. So the kinetic energy part is taken as 0, and then there's a Harty idea where this one electron is taken as a center, and that electrons distribution is taken as that electron cloud. But still we have that wave function term, which is further modified as Hartree-Fock approximation, and this Hartree-Fock approximation and Salice's determinants. So these are that mathematical terms, and then the Thomas Fermi model, and that this is the introduction of electron density term in density functional theory, which is further used in HK theorems, Hohenberg's theorems given in 1964, and then this is that mathematical terms. Now we are using that electron density with this exchange correlation function. Okay, so these are the mathematics and some theorems where we are using this electron density in place of wave function. Now this is the one self-consistence process where we start from the initial case of this wave function, and then this is that charge density term, electron density terms. This is the probability based term. Then we calculate this exchange correlation potential, and when you solve this quantum equation, then we get this new charge density up to a particular level, and if we not get that targeted charge density, then this process is just a rebound and work further for the several iterations. And we use this local density of approximation, generalized, and that generalized gradient approximation in our studies. And if you want to know the details, you can go to some good books for these terms. This is local density approximation of charge density, and then this generalized gradient approximation. In general, this GGA is taken as a good approximation for a reliable result. Then the pseudo-potential term. This pseudo-potential is actually that the effect of that core electrons and nucleus on the pseudo electrons, means valence electrons, and that resultant potential is known as the pseudo potential. And in general, in our tool, we use this non-conserving pseudo potential. Now, so actually, this talk is about 40 to 50, 45 minutes, but I am trying to cover within that given span of time. So we have different DFT based tools. Maximum tool, most tools are commercially available, but this SISTA, this is one tool where I am using here, and that is a tool which is free of cost available. And this is the website of that SISTA, which is a very well documented tool. And Why this sister? Because this is not only a method, but it's a computer program which actually balanced the accuracy and the computational time. Main thing, many times that new researchers or anyone who wants to restart that computational modeling, computational study, they generally think that we need to HPC to start that molecular modeling or this type of study. But now, after invention of such tool like SISTA, it's not true. Even if anyone want to start, one can start from this i3 with 8 GB RAM, and nowadays there is SSD are there. So 512 SSD, 8 GB RAM, 16 GB RAM, one can start this SISTA, and you can get a good result up to 40, 50, up to 100 levels, 100 numbers of items. This is the general one FDF file. Actually, that computer is a dumb box. We have to give all the information to that computer. So we need to have one input file, and this is the format of that input file where we give the information of that system which we want to study, about its water, the number of atoms, number of species, and its coordinates, and very easy to design this input file, and also that pseudo-potential file we need, and one sister tool, and one can download that sister tool by internet. And this is well documented. We have good manual tutorials and that mailing list where we can put your problems facing during that one. If anyone start, then in general I suggest to start from this channel developed by me, and this is especially for the beginners, that one can start after MSc or even after graduation using this channel. Here I have started this with what is this material modeling and how to start research work using these tools. And many good lectures, experimental lectures, as well as theoretical lectures are density functional based theories are also included here in different workshop organized by me. I have completed about 8 workshops on this SISTA as a resource person in a different part of India, and also some online workshop I have just uploaded in this YouTube channel. Also, I have designed some good script to help students, and these scripts are available free of cost to the students with demand. And these are that base scripts, so you can ask me if you are interested. These are some tutorials available in my website. That website is not updated, I know, but these tools are still available there. Now, some result from my lab. We have studied using the DFT, especially because in experimental also we have designed some good polymeric composite materials and fabricated supercapacitors, solid batteries, etc. But here I am presenting that polymeric materials in DFT studies. This is good biopolymers named as ketosan, and we have studied this transport properties and electronic properties of this ketosan. This is a natural polymer available, present in the sea coast, and one can give, and also this is a very good biocompatible material. Just you can start searching what is ketosan and how it's useful. It's a technologically very useful materials, and we have studied computationally using this. And one of my PhD student, Upma, had received her PhD of this work. And also we have studied the same materials and the effect of orientation. This is the beauty of that DFT. Then we can manipulate atomic level to that material. And what we have studied here, we just put that one monomer of that polymer, and we start rotating second one with different angles, and we have observed the change in its electronic as well as transport properties. And such type of behavior is shown in that molecular level switching system. Molecular switching is that when the one it works like a switch. When we orient in a particular angle, there will be no current. The current is zero. At a particular angle, when we rotate that particular, it's giving good current. So this can be used as a molecular switching. So we have suggested using this one. Next one is some non-essential effect of non-essential proteins on D-glucose. This is one of the studies done by one of MSc students that Dipti Patel under my guidance. She's now in Canada doing her PhD on the basis of this work. And also, this is a good, this is related to that diabetes batch studies. And we have studied the different properties of this particular molecule. Now, some polymer-based studies for the batteries related to batteries application. Here, this silver iodide and interacted with the PU. Generally, that theoretician just predicted that this silver iodide, that silver iodide interact with the oxygen of this PO, and we have verified, validated those theoretical result using this DFT, where we have taken this PO that five numbers of oxygen with this silver iodide and studied its electronic and band structure especially. This is the DOS studies. So now the next studies related to that lithium chlorate and interaction of this. Again, this interaction is showing, and also that its mechanical strength is observed in this, in presence of this salt and in absence of this salt. We have studied its mechanical property, the strength of this polymer. Even for the device fabrication, the strength of material is very important. Many times that one polymer is showing a good properties, optical properties, electro-optical properties, but if it's not mechanically strong, then that polymer cannot be used for the device. So that mechanical studies are important, and theoretically one can use that one can study that mechanical studies. And also there is that PU with NaI complex for sodium batteries, and then one more polymeric studies for the optical properties of solar cell based studies, organic solar cell based studies, that we have studied this P3SG before simulating its behavior for the solar cell, and this is good optical properties. So one can have the studies of these optical properties. Now, one Kevlar, which is used for that bulletproof jacket, we have studied its mechanical strength using a DFT. So this is that molecules of Kevlar 29, and this is that plot when we have studied its tensile strength and compare this tensile strength with experimental, and it's a good publication published in Bulletin of Material Science. Now, also we have started studying that biosolar cell, where that chlorophyll based studied we are performing theoretically, and also we will start studying experimentally this chlorophyll A, chlorophyll B, D and F, and this chlorophyll B is observed as one stable, and we have studied its structure as well as that optical properties of this chlorophyll, and it is under publication. So I'm not going to the details of this. So again, we have studied all this. So this optical absorption of this chlorophyll, it's in the visible range, and obviously this will be good for that solar cell, of that biosolar cell type applications. Thank you. I think just we put on the time. So save electricity, save water and oxygen, and I can just say that this DFT based studies, this will be good tool to study polymeric. Okay, thank you.
Ladies and gentlemen, please join me in expressing our heartfelt appreciation to Professor Dr. Mohan Verma. His presence and unparalleled expertise in the enlightening presentation on computational material modeling, electronic structure theory, and computer experiments through CSR have truly enriched our gathering. The profound knowledge shared has left a lasting impact, elevating the essence of our conference. We commend Professor Dr. Verma's dedication to advancing the field, and we deeply respect and acknowledge his invaluable contributions. The caliber of our conference has been significantly enhanced by his participation, and we are sincerely grateful for the exceptional insights he has generously shared. With utmost admiration and regard, thank you, Professor Dr. Mohan Verma, for gracing us with your expertise and wisdom. Now I would request the participants, if anyone have a question, please raise your hand. Your involvement is greatly appreciated.
Anyone? If you are interested, you can mail me. Uh, Many international students are working on this field, and uh, directly, indirectly, I am guiding them. So, if anyone interested,
Same, sir.
that even starting from that BTech level and MTech, MSc, PhD level students are working, because that's a really very interesting field of research. So, once you start, and even I am designing one a course on this, and very soon I will going to launch that. I think from January or mid of December.
Excuse me, sir.
Yeah,
Can you provide some information about DFT approach, please?
out.
DFT approach.
DFT approach is really a good and easy approach to study the material. And there are numbers of lectures available for the simple DFT. If you want to go to the mathematical term, then this is the conversion of Schrodinger equation to Poisson equation. But if you want to go to that term up to the level of that tools, then you have to start learning a particular tool. Just I am using Sista. People are using a quantum espresso and other tools also. But I found this Sista is easy to learn, and if you want to start, you can start. And my channel is there to help you to start. And just install that Ubuntu or any Linux operating system, and start learning. So it's easy to learn. Within 15 days or 20 days, you can start working after learning. Is it?
Yes, thank you so much, Dr. Mohan.
Okay. Thank you, ma'am, and thank you the
Thank you so
organizer.
much.
I want to invite Dr. Adnan, who is director of IM Group of Researchers and always being a great sport for us, for his conclusive remarks.
Assalamu alaikum, dear valued guests, participants, and esteemed team. Is the fourth International Conference on Life and Chemical Sciences with the theme From Lab to Life, Emerging Trends in Biological and Chemical Sciences come to an end. I want to express my sincere gratitude and pride for the success of this event. On behalf of the organizing committee, I want to thank our guest speakers, participants, and especially the dedicated team that worked hard to make this conference happen. Our goal focused on providing valuable education and raising awareness through research has come to life through the lively discussion and knowledge sharing during these enlightening days. Organized by the IM group of researchers, this conference provided a common ground for the students, researchers, scientists, and professors in life sciences and chemical sciences to share insights, experiences, and the latest advancement in their fields. The objective we set for this conference were not just met but surpassed thanks to active involvement of everyone present. We successfully encouraged collaboration between experts in biological sciences and chemistry, opening doors to innovative solutions for global challenges, discussions on healthcare, drug discovery, sustainable practices, and the exploration of chemistry, of nature, and biomolecular sciences have undoubtedly advanced scientific understanding, paving the way for future breakthroughs. I want to express my appreciation for the commitment shown by participants in promoting ethical chemical research, environmental awareness, and safety measures. This conference has not only been a platform for an intellectual exchange, but also a catalyst for building a community of responsible researchers dedicated to making positive impact on society. Uh, Special thanks to our distinguished guest speakers whose expertise enriched the conference and to every participant who actively contributed to the discussion. My gratitude also goes to the organizing team whose careful planning and ensured the smooth flow of events. I am confident that the knowledge shared and connection made during this conference will go beyond these walls and make a lasting impact on the laboratories, classrooms, and research institutions represented here. As we part ways, let's carry forward the spirit of collaboration, innovation, and ethical responsibility that defined the fourth International Conference on Life in Chemical Sciences. Thank you all for your unwavering support, and I look forward to future endeavors that continue to push the boundaries of scientific exploration and social impact. Thank you all.